Hello friends, I welcome you all in this lecture. In this lecture, we'll discuss about what are the usable forms of biomass. It means in which forms we can effectively use the biomass and what are the resources of the biomass. It means from where do we get the biomass. So first we'll see about the usable forms of the biomass. So here there are 7 enlisted forms of the biomass are shown. We'll see one by one. So these are the fuel wood, then charcoal, fuel pellets or briquettes, then biodiesel, bioethanol, biogas and a producer gas. So first one is the fuel wood. So basically this fuel wood is having energy density about 16 to 20 megajoules per kg. Or we can convert this fuel wood into charcoal or producer gas. So this fuel wood is the basic source of energy, and this can be used for the cooking and some other heating purposes in the rural areas by combustion process. So it is the natural metabolic process in which the carbon from the fuel wood that can be interacted with the oxygen in the atmosphere to produce the heat, as well as some byproducts like carbon dioxide, carbon monoxide. So this is the process of combustion which can be produce heat from the fuel wood, but it is highly inefficient method because only 5% of heat is obtained from this method and remaining heat is lost due to incomplete combustion and the radiation losses. So this is the drawback of this particular form of the biomass when we are using in the raw form. So that we are going to convert this raw biomass into some higher energy densities to get some higher energy densities like all the other forms which has been enlisted. But still half of the world population can be depend on this fuel wood for its requirement. So this is about the fuel wood. The next we'll see about the charcoal. So here the charcoal is somewhat higher in energy density, that is 30 megajoules per kg. It means if you are going to take 1 kg of charcoal and 1 kg of fuel wood, the energy produced is from the charcoal is almost double to that of fuel wood, because it contains 70 to 80% of carbon, and this charcoal is obtained by carbonization process of woody biomass, that is the raw biomass, and this can be used in a specialized application in industries because it contains high carbon and low sulfur content. The next we'll talk about the fuel pellets or the briquettes. So this is a simple solid fuel which is being shown over here in this diagram. It consisting of rods having 1 centimeter diameter and about half foot of the length, and this can be produced from the raw biomass like wood chips, or I can say fuel woods. So in this method this raw biomass is treated so in order to increase the energy density by compression of this combustible material. First this raw biomass is converted, that is fuel wood or wood chips are converted into powder form, and that powder form is heated in order to remove the moisture content, and it is compressed by using binders and used in this pellet form. And these pellets are having somewhat higher energy density as compared to the raw biomass, as well as in modern chullas we are going to use this as the solid fuels for heating application. So we are going to discuss this briquettes or pelletization in detail in the upcoming lectures. So another one is the biodiesel. So this biodiesel is a non-toxic, biodegradable and sulfur-free raw vegetable oil. It can be obtained from the vegetable oil, that may be readable oil or non-readable oil. So this process is called as the trans-esterification process. Through trans-esterification process we are getting this biodiesel, and we can use this biodiesel either in a pure form or we are going to blend it with the petrol and diesel to run the IC engines. The next one is the bioethanol. This bioethanol is colorless odorless liquid oil having energy density about again around 30 megajoules per kg, which is again higher than that of the fuel wood, and it is made up from the sugar cane or some carbohydrates or starch or cellulose. So it is having a chemical formula C2H5O5 and having a boiling point is about 78 degrees centigrade. This is about the bioethanol, and same biomethanol, it is having a chemical formula CH4, and again we can use this in a blended form with the diesel and with the gasoline engine to run that particular engines. So this is bioethanol. Next one is the biogas. As of you all we know about this biogas, there are the biogas plants in the rural areas. So these are the obtained from the organic waste from the plant or from human waste or from the animal waste. So all this fermentation takes place here, and we are getting a biogas which contains about 50 to 60% of methane, then carbon dioxide, hydrogen, nitrogen and oxygen, as well as H2S. Again it has calorific value around 25 megajoules per meter cube. So this biogas in rural areas can be used as a fuel for the cooking application as well as for electricity generation. The next one is the producer gas. So this can be also be called as the syngas, wood gas, or synthesis gas, water gas, blue gas, and this is obtained by thermal gasification of fossil fuel. And again this gas has higher calorific value as compared to the fuel wood. So we are going to discuss this producer gas, how it can be produced with the gasification process in detail in the upcoming lectures. So here with this we can coming across all these 7 usable forms of the biomass. The next we'll see about what are the different resources of biomass. So very first resource is the forest. As the forest consisting of very fast growing energy intensive trees like eucalyptus, poplar, pine, oil producing plants like currants, jojoba, jatropha, which are being shown over here. So these are the oil producing plants or agricultural crops from which we are getting the biodiesel or the bioethanols, as well as from this encapsulant, which is in Marathi it's called as the nilgiri. We can get the oil as well as the wood from it, and it is normally obtained in the Australia itself. And some of the popular trees and pine trees which are obtained in the mountain range, which are the ornamental plants, and these are fast growing plants. So from this we can use the wood and as well as the wood chips. So this is the very first resources of the biomass. The second is the agricultural residues. The diagram represent here it consisting of a rice husk, then coconut shell, groundnut shell, and the bagasse, which is to be obtained after the crushing of the sugar in the sugar industries. So this is another resources of this particular biomass. Now the next one is the energy crops. So there are some energy crops like a sugarcane, starch plants, some oil producing plants from which we can get the oil, biodiesel or bioethanol, biomethanol, or from the bagasse we can get the electricity, that is which is in the solid form. So this figure represent the sugarcane plant. So there are number of uses of the sugarcane plant. After the crushing of the sugarcane in the sugar industry, whatever the byproduct is remaining, which is called as the bagasse, and this bagasse is burned in the cogeneration plant to produce the heat, and that heat is given to the steam turbine to drive it, and so does we are going to get the electricity generation. Along with that, we can ensure the alcohol generation or distillery generation from the sugar plants. Also we can get some ethanol production from this sugar plant by fermentation process through yeast and bacteria. The second figure shows which is a sorghum plants, and these are used to produce the biodiesels and bioethanols. So it's the same for the all oil producing plants. Then the next one is the aquatic plants, which are nothing but the water hyacinth. In Marathi it is called as the jalparani, which is used to produce the biodiesel or biogas and ethanol. Next, these two are the sea-based plants like kelp, then seaweed, algae. We can use it to produce the biogas as well as ethanol. And the last one is the urban waste, that is municipal waste and the sewage. So the municipal waste can be bifurcated into two parts, one consisting of a dry waste and another one consisting of the wet waste. So this dry waste is consisting of this paper, then yard trimming, then all the metals which can be separated, glass, plastic, and all the other forms like rubber, leather, textile, wood, and all the miscellaneous waste. So first this dry waste and wet waste is segregated, and this dry waste is applied to the incineration purpose, that is in the direct combustion purpose, and the heat produced by this direct combustion can be used to drive the steam turbine to produce the electricity, as well as the wet waste can be used in the biogas plant to produce the methane gas. And this is about the municipal waste. And here sewage is also there. This sewage is nothing but obtained from the industrial and human or the domestic sanitation. So this hard water, sewage water, is treated in the treatment to get recycling of this sewage waste. So here with this, nothing will going to getting waste, everything we can utilize it for a different application. So this is all about this lecture. So thank you.